Awesome. Um, so in the next hour and a half, what I wanted to kind of show was, how do you build reliable and scalable systems using Conductor? And what we will do is, we'll kind of do a workshop and we'll walk through it like, on my laptop as well. So, those who don't have a laptop or don't want to try it on a laptop, they can kind of follow through and follow along. To introduce myself, my name is Viren. I'm one of the co-founders and the creator during my time at Netflix for Conductor. Right. So I'm going to start with a statement saying that building reliable systems is hard. And more importantly, as you try to start scaling them, and the scale does not necessarily mean transaction per second alone. It can also mean your business complexity, and that becomes even harder. And we'll see in a bit as to why I believe that. So, more and more companies, most of you might also be kind of moving to cloud. And when you think about cloud-based application architecture, one thing is pretty clear is, every system in a cloud is a distributed system because, now you have different components running in different environment, probably even different VPCs. And one thing that we all know is, we would love our network to be infinitely scalable, unlimited, and 100% reliable. Reality is definitely not that. And on top of it, there are also other kind of factors that plays into it in terms of resources. Oftentimes, depending upon the kind of resources that you have provisioned, the cloud vendors might be throttling your requests and things like that, right? So failures becomes a norm. It's no longer an exception, but rather if you run an application in a cloud environment, let's say long enough, you will see a node failing, region outages, availability zone issues. It's not a question of if they will happen or not, it's a question of when they happens. And the question then becomes is that are your applications ready to kind of handle those kind of things? The other piece when it comes to distributed systems is that debugging is harder because the failure could be happening anywhere in the system, not just the end components of the system, but also somewhere in between things like network or disk and things like that. So debugging those issues becomes very critical in terms of time because one thing that is something that you cannot pay anybody to kind of get is time, right? And time to debug is critical. Once you find the issue, fixing typically is not that big of a deal. Then comes the question of business needs. Things are constantly changing. There used to be a time when you build an app, it continues to run for years and years before changes are made beyond maintenance. But in today's world, what's happening is that you see things are constantly moving. Business are a lot more tech forward. A lot of business is driven by technology, and therefore there's a lot of investment also in the technology that is happening. The needs are constantly changing. This is no longer the case where you build an application, put it in the production, and you are done. It continues to change. It's never the case where it's done is done. And final piece is that durability becomes a paramount consideration because if things are failing and if you have to constantly restart and fix things, that becomes a nightmare over a long period of time to kind of manage, right? So durability of your application code becomes very critical. And it is kind of table stakes in today's world where every application has to be durable, as opposed to you can pick and choose when you need it and not. The other piece to that also is that if you think about applications, every application is a state machine. And the reason why is when you are building an application, you often have to kind of manage the process state, right? You take, for example, payment, right? Even if in a very simple case, if you take the money from one account and put it in another account, you have two-step process and there is a state associated with it. Now, there are two kinds of states here, right? There is a business state and there is an application state. And we are going to focus a lot more on the application side of the state management. So it's less about, hey, business users looking at the process and where am I in the process versus as an application developer, how do I kind of model my application's state through something like Conductor and why that matters, right? The other piece is, every application has a kind of set of order of execution that you need to guarantee that they get executed in that particular order. If there are failures, those failures are handled in terms of, if it's a transient failure, you're going to do a retry. If it's a permanent failure, maybe you're going to do something else and things like that. So this is where the role of a workflow engine has become quite an interesting one. Workflow engines have been around for many years now, right, if not decades. And the key advantage that they provide is, they allow you to manage the state. Essentially, they are orchestrator. And depending upon the type of workflow engine that you use, right, it also handles the aspects of resiliency and failure handling, because as an orchestrator, you are the one responsible for wiring up your application together. And that means that if there are failures, you can handle those things in a central place, as opposed to every application having to deal with that individually. And other piece about workflow engine is that they started kind of in its early days to handle the complexity, right, in terms of the business complexity. But being the fact that they are inherently asynchronous, reactive, they also helps quite a bit with the scale in terms of the operations per second and things like that. And most important piece is that because now you have a centralized orchestrator who has the worldview of everything that is going on, when there are failures, and we'll see that in the subsequent workshop as well, is when there are failures, it's very easy to figure out where the failures are, why those failures are happening, and then once you find the issues, fix it and recover from those failures. So going back to the main topic for this workshop, right? Conductor is something that we had built at Netflix, and the main purpose was exactly that. We have tons and tons of microservices, events, service workers. How do you orchestrate those at a scale that Netflix operates? We are talking about tens of thousands of requests flying around every second, and given the fact that it is nothing proprietary about how Netflix does, for example, media streaming or produces content, it was made open source. We recently moved it to a foundation called Conductor OSS. It's fully open source. And what it does basically is Conductor is an orchestrator. It implements a durable execution pattern along with well-known patterns like Saga and things like that. And more importantly, it is language agnostic. So it's not specific to a language, like you are not forced to write everything in TypeScript or Python or so forth, right? As opposed to that, you can write in any language. You can mix different languages in the same application and make it work. So before we get started, right, like there are some of the core concepts that Conductor provides. Essentially, when you look at a Conductor workflow, what it does is it models your application's state. Your application state machine is kind of modeled as a Conductor workflow. And workflow essentially implements all your programming language concepts, right? As a programmers, we are used to kind of dealing with things like parallel execution, switch statements, right? If then else, or case statements, loops and things like that. So Conductor, as opposed to kind of being very process driven, it's more about, hey, there are programming concepts that we know how do we use it, because as programmers, that's how we think about things, right? How do we express that as a Conductor workflow and kind of have the orchestrator take care of things? So, you can have a series of tasks and steps that are executed in sequence, conditional, in parallel, and so forth. And when there are failures, it takes care of, showing you where the failures are. You can set up automated retries, which are actually default, and it will handle those things out of the box. And the main objective or the purpose there is, as a developer, you don't have to worry about those aspects of resiliency, code visualization, rate limits, debugging, and all of those things. You write very simple, stateless, single responsibility worker code or microservices, and let somebody else take care of all of those concerns, which also means that you can iterate fast, move very quickly. So this is what we want to do, right? Like, we want to build a very simple workflow, an application that, let's imagine, we are building a small payment transaction system. And I'm going to simplify this so that, we don't add a lot more complexity, but, if you think about it, right, like, you're transferring money to somebody, let's say you're using Zelle or Duala or any of the payment systems. Of course, the reality is a lot more complex, so we are going to simplify things here. But your step one is maybe you are putting some sort of payment hold, or you are putting some sort of validation on the payment to make sure that amount is within the limits. It's not a negative amount, so I don't end up transferring negative amount to you and getting more money out of it. Things like that. You do debit and credit and finalize the flow, and if there are issues, you kind of roll back and handle the failures and notify the users. Yeah, so as I mentioned, Conductor is pretty much language agnostic, but for the purpose of this workshop, we are going to use JDK and Spring Boot. All right, so if you would like to try it out, here is a link to the GitHub repo, and you can start the container, and I'll show you a bit how does it look like once you start the container. Once you start, you should see the server coming up and running. Conductor essentially uses multiple different backends. The default uses Elasticsearch for indexing, so you see a whole bunch of logs here. And once the server is up and running, you should see the UI. So this is the Conductor operational UI that allows you to monitor all the executions that are happening in the system, how everything is kind of wired up. You can search for things and everything. I have some examples already that I had created earlier for this workshop, so those are shown here. So that's the Conductor server, right? It's still just the platform. We still need to kind of set up our application. So I have a very simple kind of a Spring Boot based application here that does the payment processing. This is where my business logic sits, and everything is implemented. So, and of course, the repository is open source. You can check it out and start the application. So I'm going to start this in my IntelliJ, so we have a better view of the things. So here's my code is checked out. I'm going to close all this windows and start my application. Right. All right, and let's see what do I have here. So if I go to Swagger on port 7001, essentially I've got a very simple API with 2 endpoints. One is to schedule the payment transfer, where essentially you specify from which account you want to transfer the amount, how much, what's the amount, and which account that you want to transfer the amount to. And of course, you can get the status of the workflow back once you schedule it. So that allows you to kind of build out your complete UI and everything. And the app runs on port 7001 just to avoid the conflicts with the ports. And yeah, there are 2 API endpoints here. Yeah, absolutely. There you go. I'll pause it here for a bit, and then we'll continue from here. Sure. Yep. And here is the, yep, connector repo that you can check out and start the server. Should we continue or need some more time?
So I started that one before and stuff like that.
Oh, I see.
So you may not need 50 container in time. And so also it's for like OJK and no yarn. So that's why.
Oh, I see. All right, so let's, while things are getting downloaded, we'll continue forward and then we can come back here. All right, so let's look at the application that we have and we can go through the structure of the app. So this is our payment app and what we have here is, of course, we have our application. Here's a controller with 2 API endpoints that we showed earlier. And as you see, right, like when you initiate a payment transfer, it starts essentially a workflow with the payment transfer request. If you look at the payment transfer request, essentially, you know, it models after what we talked about, right? Like, you know, from which account to what account and what's the amount that you're going to transfer. And it returns back the transaction ID, which essentially is a workflow ID. And finally, it exposes an API endpoint that allows you to get the status of the workflow. So you know if you're rendering an application UI and you want to check the status of your payment transfer, you can use that endpoint to essentially get the status and continue forward from there. And let's take a look at the workflow now. So here's the JSON of the workflow. It's JSON, so like, you know, it's not easy to parse, but we can take a look at the actual definition for it. And that's the power of Conductor. So here is the workflow, right? What we are doing here is we are doing the payment validation. When doing the validation, it takes all the information in account. to see what do we want to do, what are the accounts that we want to transfer money from, what's the amount, and so forth. And I'll show you a bit in how this is implemented. In real world, probably this is go through some sort of fraud check information, maybe checking the balance in the account, and this could be a lot more complex. Right? It could take a few seconds to complete. This could be a remote endpoint that is actually getting executed as opposed to having it in process. Next up is basically a condition here. We are going to check if the validation completed successfully or not. Let's say if we had failures in the validation, then we are going to basically send out a notification to the user saying, hey, your payment transfer has failed because of so and so reason, and we terminate. But let's say all the payment information looks good. We want to continue forward. We are going to just debit, credit, and finally send a notification, and that completes the workflow. So that's essentially a very simple workflow with 4 steps in a regular case and 3 steps in case of a failure, or the 2 steps. Yeah, absolutely. Sorry. Yeah. And I'm going to just. There you go. Let me see. I think we can increase a little bit more. Yeah, there you go. And as you can see, right, what we have done here is that all the wiring in terms of what is the flow that application is going to take, which application components are going to be wired up. That's all implemented inside Conductor, and Conductor is where all this information is stored as opposed to writing in your application. That also means that if I were to add one more step here, I can just go change the workflow, add one more step here. Maybe if the validation is not necessary, or the validation itself is a 2-step process as opposed to a single step, I can add one more step here. It becomes very easy to go and change things. One more thing, if you notice here, is that this one has a versioning. And if you notice here, right, I got 3 different versions here. Let's see, yeah, my first version or my previous version basically was completely sequential. Like, let's just go boom, boom, boom. But then I realized, wait, what happens if validation fails? How do I handle those things? So that's my next version. So, I can also see the changes. And if, of course, if you have a new version that you want to roll it out in production, maybe you want to do some sort of canary testing, send a smaller traffic there, look at the business metrics before you roll it out to everybody. So those becomes pretty trivial, and we'll see how. So that's my workflow. Going back to my code, as you can see, right, my workflow name and versioning is kind of injected as Spring Boot properties, which means that if I want to change the version from one to something else, I can easily change that. And of course, then I can drive this using different configuration management system, change those things runtime, or do traffic redirection, all of those things. That becomes just out of the box, depending upon how your things are set up. Now let's talk about implementing those different steps. So what I've done here is I have a Spring Boot component marked as a service, and all my implementation is here. Of course, in a real world scenario, this might be a different class per component. This could be a lot more complex than just either just no implementation or just doing a log statement, or it could also be making calls to your internal systems and so forth. So here is my first step. What I've done is I have a simple Java class that does the payment validation. This is my validate payment method, and this is the implementation. For the sake of demonstration, what I've done here is that if you're trying to transfer more than $1,000, it throws an error and returns back. I could also throw an exception here, but for the sake of this demonstration, it basically returns a map. You could actually return a POJO also here, just like I'm getting a payment request as an input here. Then next thing that we are going to do here is that we are injecting some sort of random a transient error condition, right? So we're generating some random number. So what we want is maybe 50% of the time we want the requests to fail. Just imagine that this payment validation is making calls to an API or is talking to a database, and there are problems. Maybe database is under heavy stress. Maybe there are network issues, and a lot of API requests are failing. Now, if you are building a real application without Conductor or a framework like this, you will have to handle all of these things yourself. And we'll see in a bit, this becomes almost a trivial pursuit here. And finally, we return back the response. Similarly, debit, credit, 2 steps. There's no implementation here. Setting notification, we want some more details here, right, in terms of from where to where and all of those things, including the status. So that's another log statement here. This could be something that sends out an email, maybe gets the user information from a database before and figuring out what their email address is. If they want notification to be sent over a text message, then maybe it is calling some API to send out a text message and things like that. But my worker implementation is straightforward. One more thing, if you notice here, that my workers are completely isolated from each other, right? They don't know the fact that they are part of a workflow. Like, for example, this payment validation is very stateless. It gets the payment transfer request, it does its job, and returns the value. Now I can reuse this for payment transfer. Maybe there could be other use cases where I want to use it. I can use that. Similarly, debit or credit steps. What if I wanted to make it part of, let's say, a shopping cart transaction where I want to kind of take the money out of an account? I can reuse those things as well. Where I see the broader use case is probably the sending notifications, right? Where you might want to send out notifications to users. So this could be a service that is very highly used across the org, and maybe it's implemented as a different worker. Maybe it's deployed in a different container. One more thing is this workers here, this is a Spring Boot application, but in production environment, they all could be deployed as part of a same container, or every component here, every worker could be a different container, or you could club together things that depending upon your workload requirements and things like that. Now, how does this application know which conductor server to use and everything? So, in my application, I'm pointing into conductor server. In this case, it's a local host, but your production environment could be your internal endpoint where the conductor server is running. And my workflows are checked in here, so this is my workflow. And what I'm doing here is that when my application starts, here is my post construct. I'm reading those workflow JSON and registering them on the server. So if I want to create a new version of the workflow, I can go create a new file here or modify this and register that. So every time application starts, it can register. And then you can apply different strategies. This can be part of a CI/CD. This could be part of your application bootstrap process. So depending upon how you want to manage those things, you have kind of freedom and choice there. So let's go to the actual execution now. So what I'm going to do is I'm going to go ahead and start, let's say account 1, account 2, and I'm going to transfer, let's say, $10, right? This should succeed. So it starts, it gives me the ID because that's what our system does, at least our API contract. Now if I go back to Conductor UI, I should be able to see this. I'm going to copy this. Put the workflow ID here. As you can see, it has completed. It executed the step 1 here. It got all the information here. It produced the output saying, it's okay, and it continues. Now, if you notice here, this particular step, right, payment validation, it ran 4 times, out of which it failed 3 times, and on the 4th attempt, it succeeded. And the reason for that is, we have transient failures, right? So it's going to try a few times before. But if you look at my code does not worry about those things, right? All I'm doing here is that, if I can't process the request, I'm just throwing an exception. If I'm calling a database, this could be my SQL exception or anything, right? I don't necessarily have to handle any cases here. What system did was it did an automated retry. Why did it did 3 times? If you look at the definition here, you will see that it has a retry count set to 3. Also, If you notice, it completed very fast because I put in the delay of 2 seconds. Otherwise, you'll be waiting here for 2 minutes. But in theory or in practice, you want this to be a higher number with a specific retry logic, and we'll go into that as well. System kind of goes through one by one here, and it completes. One more thing here is that if I look at every step, I know what's happening here, right? I know ID of this execution. I know when was it scheduled, when it start, and it took 17 milliseconds to complete, and this was the host name when it ran. If you are running on Kubernetes, this is probably going to be your pod name. If you're running on a bare metal or a VM, this could be a host name or an IP address. You can change those things, and it helps you figure out where the failures are. So for example, this payment, I would know that this was the host where it failed. This is the reason. I will be able to see the struct trace here also. So I know this is the line number where it failed. So if I have access to source code, I can go back to the code, look at line number 30. Okay, let's look at line number 30. This is where it is failing, right? Super easy. I know exactly why it failed, where it failed, which host it ran. So if I have to go and look at more contextual log on the pod, I can either log into the pod, or if you have systems that allows you to aggregate logs from different pods, you can know exactly what queries to put filters on and get the information. But now time to debug becomes very quick. Now going back to our configuration for this payment transfer, what I've done is this is my configuration for it. Right? Let's see if I can increase the font size here a little bit. Or maybe that's fine. All right. So what I have here is that I'm going to remove some of the things that are a little bit not useful here, so it's easy for us to look at it. So the important thing here is this, right? We are talking about payment validation step, saying when there are failures, it's going to retry 3 times on top of the initial attempt. Between the retries, it's going to wait for 2 seconds. And my retry logic is a fixed retry. This one can also be linear backoff. In that case, the backoff scale factor applies. Or this could be also exponential backoff. And then it will do exponential backoff there. One other thing, if you notice here, is there are a whole bunch of timeouts here. And there are 3 kinds of timeouts that Conductor provides you. And I'm going to put it here. And one thing that's not shown here is port timeout. So what happens if a task or a step takes longer than expected? Imagine a case where you are talking to a database, the query is taking longer and longer, the whole application comes to a halt, right? You want to probably abandon that transaction at this point of time. So you can specify the timeout. Let's say in this case, I don't have a timeout, but I could say, this is quick enough that it should complete within 5 seconds. And if it takes more than 5 seconds, you should do something. What to do here is what you define as a policy. Other thing is, what if you schedule a task and there is nobody responding to it? So let's take a look at it, what happens there. I'm going to undo all these changes. Give me a second. Those changes. And what I'm going to do is I'm going to essentially comment out this worker task. And I'm going to restart my server. So what happens when you have an underlying system that is currently not running or not polling, right? We started a new workflow here. This is my ID. Go to executions. Go to find this. If you notice, it's running and it is scheduled. My API call is finished because the whole call is completely asynchronous. If I give the state of this ID here in my API call, I should be able to figure out that, hey, this payment is currently in process, here's the running status. And if I want more context, I have a list of tasks that are currently. And I know this payment validation is currently scheduled, which means it is waiting to be scheduled. And now this can happen for multiple reasons. One is that there is no one working on this particular task. This could be because maybe the deployment had failed, there is underlying kind of system issues and things like that. Or this could also be because things are kind of backlogged. If I want to know, if I go to task queues, and if I look at validate payment details, I should see that no, it has one pending task. So I know how many requests are currently pending that is waiting to be executed. This information, by the way, also is published as a metric. So, oftentimes what I have seen people do is they connect this to a Kubernetes-based autoscaler to automatically scale up or down their workers. So it is running. This is where the timeouts will help. If you have a timeout, it can fail the workflow. And workflow fails, you could have policies that will trigger some alerts and things like that. Maybe somebody gets a paged, and they take a look at it and fix it. So let's say somebody fix it. Now deployment is done. I'm going to restart, and we'll see what happens. Completed. If you notice, right, as a developer, now I'm not worried about like what happens if the underlying system is not available. I just work and write my code as if everything is going to be always working. There is going to be no failures. System will heal itself automatically. Now, if you are familiar with things like Saga pattern, you would have seen that, like, you can also oftentimes, in a distributed environment, to compensate for failures, you can also do things like, the compensation. Now, the way to do that in Conductor would be to have a workflow that takes care of the failures. So, we have a workflow here that I have created. All right. It's a simple one-step workflow in this case. But of course, this can get a lot more complex. You could have steps here that would essentially reverse the transaction. Maybe if you put a payment hold, it can reverse the payment hold and things like that. And what you would do is, in your main workflow that you have, you specify a failure workflow. So this is the workflow that gets executed when the overall workflow fails. And let's try that out. So what I'm going to do is our favorite step. Let's look at the debit account, right? What I'm going to do is I'm going to throw an exception. Okay, say. So I'm going to fail this permanently. And if you notice, I'm throwing a non-retriable exception, so it doesn't try. There's no point. Execute this. Go back to UI, passing the workflow ID, and this has failed. So now, if you notice here, again, debugging this particular flow is super trivial. I know my validation succeeded, but while trying to do a debit, that's where it failed. Again, I can see the line number, which file and everything, what was the input. Maybe the account ID had a problem, and therefore it failed. So all this information is available to me now. And when you look at the failure, it started this workflow automatically, right? And input to this workflow is my entire workflow. That this is the parent workflow that failed. This is the ID of the workflow. The payment validation had succeeded. So I'm going to close this. My decision was successful, and this one failed. Right now, if I had put in a hold on my account, then I can go and remove the hold, for example. Right? Let's say if you're putting a hold before transferring the money, and if the transfer failed, you want to kind of remove the hold. So that will happen automatically. And probably I'm sending a notification to the user. I'm sending a status equal to failure. So maybe this task then constructs a nice message saying your payment transfer has failed for so and so reasons, and maybe you should retry and things like that. And again, like as a developer, I am not really writing any specific code to handle try catch or anything. Also, it means that like this process of compensation can get a lot more complex, can be completely decoupled from my parent workflow, and can evolve independently, right? Let's say oftentimes what happens is you are going through the journey where like you are refactoring applications. Conductor lets you kind of take care of taking the existing code, use it as it is, as we saw that, right? And then maybe as things kind of evolve, you can kind of evolve this, right? I can start adding more tasks here. I can start making this lot more complex, and things like that. Yep. So Conductor has a very flexible backend. Let's take a look at the GitHub repo here, and I'll show you. It has pretty flexible backend. So it supports Redis, Cassandra, MySQL, Postgres as their kind of primary storage. When using things like Postgres, you can also use Postgres for indexing, so then you don't use Elasticsearch. If you are not using Postgres, then Elasticsearch is used. Indexing is not critical to running workflow, so let's say if your Elasticsearch server is down, your indexing will not happen, but your existing flows will continue to work. Only your primary database has to be up and running. Everything else can be down. Yeah.
Your tasks keep tracking all the inputs and outputs.
That's correct. Yeah.
PII data. So how does the data security?
Yeah. So when it comes to PII data, one is the Conductor server is running in your infrastructure, which means that like whatever practices that you are following with your existing applications, you can kind of follow those things. Things like, for example, if you are making an HTTP call, like Conductor supports making HTTP calls through a direct system task as opposed to you writing the code. What happens if you want to pass in an authorization header, right? So you can configure secrets and use those things. One more thing is that, and those are masked and not indexed. So basically, standard practices apply there, and it helps you kind of do those things.
Does the data get encrypted on REST?
So yes, depending upon your setup, right? Let's say if you're using Postgres, pretty much every cloud vendor, and you can do encryption at rest, encryption in transit, so you can have fully secure end-to-end. Yeah, even your endpoint, typically you want to expose it over HTTPS. Yeah. One more thing is that the workers, when we saw here, right? The workers that I'm writing here, they all talk to Conductor server using standardized HTTPS or gRPC. And those connections are always outbound, which means that, let's say, an application that is talking to Conductor server does not need to open up new firewall ports, and nobody talks to them inbound. It's always an outbound connection. So that simplifies your networking and security controls from that perspective. And because it's HTTP and gRPC, it's standardized the ports there. Yeah. There are things like, for example, like if you are handling with PII data and secrets and everything. So the open source does not have those things, but like if you're using Orkes, for example, then those are one area where like as an enterprise version, we have support for handling PII data, secrets, authentication, and things like that. Right? So you can safely kind of share the workflows within the organization and things like that. Yeah. Now let's look at one of the completed workflows here. So we saw the diagram here. You can also see summary, but more importantly, you can see a list of tasks, and this is useful when, in our example, we only have 5 tasks, but like this production, if this is a real production workflow, it's safe to assume that now you have tens of tasks here, right? And we have seen companies and users with, literally thousands of tasks here. One other thing it kind of gives you is a timeline view. So it's a waterfall kind of a timeline view of how everything is kind of wired up. And by the way, all those numbers here are in milliseconds. So when certain things got executed, when it started, completed, like this particular task of payment validation took 23 milliseconds. Now this might be okay, this might be too low, and things like that, right? So it kind of gives you an idea. So imagine a situation where your payment transfer is taking longer than expected, and you want to improve the efficiency. You can take a look at it and see where time is being spent, where are my opportunities for improvements and things like that. This data conductor also publishes as aggregate inside Prometheus or any open telemetry compliant metric system. So you can also get an aggregated view of how many tasks are running, what's their kind of average or P90 or P99 latencies, and based on that you can make decisions when to scale things, where to improve and things. You get a complete visibility of your systems out of the box. And final piece is, yeah.
On the timeline, you saw all of the gaps between the actual tasks. Those are all orchestration time?
This is a combination of two things. One is, orchestration time, but also if the workers are busy, then the amount of time it takes for them. Yeah.
Is there a way to mention this?
Yeah. So your worker, you have kind of several ways to kind of optimize those things. One is, being more aggressive about polling interval. The default is 100 millisecond, so you can shrink it down to 10 milliseconds. So that's your worst case scenario. An idea is that workers, if there's no work to do, they will wait for 100 millisecond before polling the server. But you can shrink that time. If there is work, they will constantly poll. Yeah.
I'm thinking if there is a specialized worker which sort of ends up getting a lot of rates.
Yeah.
What is the way for me to figure out from this? This is what I need to scale.
Yeah. So the information goes into a metric system. So let me see if I can pull up one of the metric dashboard here, and I can show you. I need to probably connect to a different Wi-Fi here. So this is my Grafana, where I'm publishing for one of my servers. Okay, the network has a problem here. Okay, there you go. So you can basically visualize those things, right? You know how many tasks are pending at a given point of time. This is all coming from Conductor server, by the way. You know also how many tasks are polling every second. So this is my dev server. I have about 1,000 requests happening every second, polling for tasks. My polling latencies are about 15 milliseconds. So now I know, how long is it taking for a particular task to poll for, and then looking at the outlier, I can go and fix those things. So these metrics are available that you can use it to kind of go and make decisions and improve systems. All right. Now, I talked about the workers being polyglot, so I don't necessarily have to write everything in Java. Here is my Python set of workers. So similar principle applies. You can have workers that you write in Python, similar things. You annotate them as a worker task, give it a name, and it also supports data classes. So you can create a data class for your inputs and outputs, and the same thing, yeah. Which means that one of the steps could be written in Python, other step could be in Java, third step could be a C#, and so forth. Now let's say if I were to kind of improve this workflow and evolve this further, this can get, this is already sufficiently complex, but I can also put the loops, parallel execution, and so forth. So things are can get a lot more complex and a lot more complicated than this. So we talked about this. Yeah. All right. Any other questions? One more thing is the indexing is done in a external system like Elasticsearch or Postgres, so you can retain data for much longer period of time if you need to, and that could go from days to weeks to months to years, depending upon your policy and how much data you want to kind of retain, and that helps oftentimes in terms of analyzing the previous executions, in terms of debuggability and things like that. Awesome. So one more thing is, if you are dealing with microservices, you don't necessarily have to also write the code to make the API calls. There's a notion of an HTTP task in Conductor that you can directly use. So like, here's my kind of playground, and let's show you an HTTP-based workflow. What you can do is, you can essentially create a task called HTTP, and also specify all your parameters in terms of what is the method, get, push, post, payload, and everything. And the server will take care of making HTTP calls for you, handling retries and everything that we talked about, right? So what Conductor does is that there are pre-built tasks in Conductor, and you will see those things here. In the open source repository as well, that lets you kind of do those things. And some of those things are things like, for example, using an inline JavaScript worker, so that if you want to do lightweight processing of data, you can write JavaScript code. There is a library called JQ, which, if you think about it, right, is a command line processor for JavaScript, or JSON files rather. You can also use JQ tasks to kind of work with the payloads in Conductor. Similarly, if you want to publish a message to an eventing system like Kafka, Nats, RabbitMQ, those things you can do it out of the box without having to write the code, which also means that if you are integrating with your internal systems in the organization, those things can come out of the box without you having to necessarily manage those things. And of course, it's open source, so if you see something that is missing here, feel free to send out a pull request. Awesome. Great. Yeah. Also, help spread the word. Give it a star on the GitHub repo. We have a community. I think if you go to GitHub repo, there is a link to the Slack channel. So if you have questions, you can join the Slack channel. Most of the committers, they hang out there. So if you have questions, you need a feature request, you find a bug, yeah, everything. Awesome. Great.